Thanks for attending. Thanks for being here. We're going to talk about benchmarks and scalability studies around Alfresco. I think it's quite of a good presentation after Romain performance troubleshooting session. So we're one step forward here. Sorry, it doesn't look like I can stay here. It's not really comfortable, but so what do you think? Here? Yeah, well, as long as I can, do stuff. Can you hear me? Yeah? Okay, good. So I think in Romain's presentation, it was really interesting to see, all the areas that you can look into for troubleshooting and make, understanding what are your issues with Alfresco performances. We actually use many of those techniques in the benchmarks that we're going to discuss about today to prove that Alfresco can actually reach certain levels of scalability. And the good thing is that we have numbers here. So we're going to cover a few areas today. Obviously, I would like to spend just a little bit of introduction, understanding what do we mean by ECM scalability. And I think already Romain presented some interesting inputs there, meaning we'll see that there's no such concept as general scalability. Really, it depends on what you're doing on the platform. So again, it was a very good thing that we had the two sessions together, so you have a sort of continuity there. We will be going through the scenario and tests that we have been running in the last year around benchmarks. Obviously, we have the numbers, so you don't have to trust me when I tell you the Alfresco scales, also because I understand trusting an Italian. It's not really the easiest thing in the world. So, and we'll obviously then discuss a little bit of the techniques that we used and the tools that you have available yourself to actually run benchmarking context. I think that's fundamental. One point is definitely understanding the scenario, the load that you have, but also the environment in which you're running them. It's can be a critical differentiator with respect to the numbers that you're going to see today. So let's move into the first bit of the presentation. As I said, there's no such thing as one size fits all. I just want to start with this is a little bit of a last year I gave the same presentation at DevCon, and I tried to make clear that I think that's something that you should already know if you work in large Alfresco implementations, but the default Alfresco distribution that you download is actually tuned for a little user evaluation. So it's equally tuned for 5 to 10 user evaluation. So there's no way that you can take that thing, put it in production for a very large, complex, scalable use case, and just have it work. Also, there are many other components at the Alfresco scalability. It's not only the platform; it's also the number of, and obviously Romain introduced that very well. There are many number of components that are related to and that Alfresco leverages to deliver its services. So you really need to have an idea of what the context that you're running in and what exactly is the scenario that you're running in. I think I'm not going to go into the detail of this quote, but I think it's a very interesting one in terms of when you're doing benchmarking, when you're doing scalability, the definition of the scenario is definitely the key factor that allows you to do a proper statistical study. There's no such thing as ECM scalability per se. So how scalable is your platform? A certain platform can have a scalable ready design, can be designed for distribute load across different tiers, and obviously there are inherent capabilities that allows you to scale. But it really comes down to what you're doing with the platform. And as you know, Alfresco has a vast ecosystem of solutions that you can build on. Alfresco is a content platform. You can use it for web content services. You can use it for enterprise collaboration. We have multiple customers even using it as a headless content platform, if you want, as an API-based content backend, without even using any user interface. You can definitely understand how, use cases, the core Alfresco use cases, or even the extended Alfresco use cases, if you go more into the social content management, integration with external collaboration platform, or even cloud scale implementations, require very different benchmarking, and obviously have very different requirements in terms of tuning, architecture, and design. So let's try to, since we're going to use a certain jargon, if you want, the benchmark jargon in the next slides, let's try to define a couple of common points that I think are important to speak the same language in the next slide. So as we said, definitely benchmarking and scalability study is scenario-driven. What we will be discussing today is really mostly the enterprise collaboration scenario. So if you want a global Alfresco deployment using Share as main user interface, we're talking here, we have customers who deploy Alfresco to even 100,000 employees if you want. So imagine an intranet, imagine a global collaboration platform for an enterprise. We said already, there's no point of testing out of the box. Out of the box will poorly go up in number of users or content. You need to know what Alfresco relies on and what are the components of Alfresco for your specific use case. Obviously, the most intuitive measure that we're going to take out of this benchmark that we're going to refer is the average response time. As Roman was saying before, that's not enough. But especially when you're doing more statistical analysis rather than performance troubleshooting, obviously on a global level, that gives you already a very good idea of how the system is performing. So we'll see, we'll present results of Alfresco benchmark relating to, average response time for all the operations that we are running against the system. Load distribution is definitely a key factor, and obviously that more goes into the sizing area as well as stability of your system. But Alfresco is a quite distributable platform if you want. We have a content tier, we have an indexing tier as of Alfresco 4. We have supporting components like database and content store. So you have many capabilities to actually distribute the load, and I think that's one of the key factors that you need to take into account when you are deploying highly scalable Alfresco architecture. In terms of input factors or characteristics of the scenario, obviously the most intuitive items are the amount of content in the repository, and here typically we are more interested into the number of nodes in the repository rather than the size of the content store itself. Really, Alfresco, in terms of indexing, in terms of content management, the biggest load is really on managing a large number of documents rather than a size. As you know, Alfresco stores documents outside of the database. Therefore, we don't have scalability problem from that standpoint. But obviously, a very large number of content might require different tuning and different capabilities, as well as obviously the number of concurrent users that are hitting the platform. Before really running in the benchmarks, discussing what we ran in the benchmark and presenting the results, I think it's mandatory, and I'm not sure how many people of you are already using Alfresco 4? Okay, that's a good amount. So I'll try to be quite brief here, but there have been critical architectural changes between Alfresco 3 and Alfresco 4 in order to enable scalability. And I'm going to just quickly run through those so that you can really understand how a scenario can map into load distribution on the different components of Alfresco, and which underlying components are actually stressed by a particular type of operation. As you know, and I suppose most of you know, Alfresco 4 introduces a separate indexing tier. So we used to use Lucene in process. We now have a separate and separately scalable indexing tier. So we will see how this might impact how many instances of Solr rather than repository you have to deploy, just to be practical, in your architecture, depending on the scenario that you're running, whether it's more search intensive or content management intensive, for example. We have the concept of eventual consistency. This is really a deal maker, if you want, a big change in Alfresco 4. We used to push index updates within transaction in Alfresco 3. This obviously allowed the index and the database to be in sync at any single point in time, but doesn't allow, highly scalability was found as a potential, bottleneck to actually grow, to a cloud scale type of scalability. So you gotta know that right now there is Solr actually tracking the content in the background. Therefore, we don't have this huge indexing overhead while creating, updating, and deleting documents. These are two separate processes, and we will discuss that and the implications of this in the next couple of slides. This is not really the main focus of the presentation, but for you to know, if you followed also the presentation of Mark Rogers, we have support for clustered file systems that used to be there, that used not to be there in Alfresco 3. This means that right now, same as you can do with a web interface, with a share or any APIs, you can also cluster your CIFS or FTP interfaces that are exposed by the Alfresco repository. I think this is really interesting, not really for the purpose of the talk of today, but for you to know that basically you can transparently scale Alfresco independently from the user interface that you're using. One big point that changed, and that's probably less intuitive than the others, has been the where and how the ACL evaluation gets carried out. So in Alfresco 3, pretty much the search results ACL evaluation, so enforcing that only the right person could see the search results, was an additional process done after the search. In Alfresco 4, this has been moved to the Solr tier. This means that in flight, when you are executing a query on Solr, automatically results get filtered for the current user, so that the current user can only see results that he has access to. This is a big change. This means also that Solr has to keep information around the ACLs. So it has to track the repository for ACL updates so that it can really enforce them at query time. So these are a few areas that I think you should be aware of when you are designing an Alfresco 4 scalable solution. And obviously, we had to take care of, and we actually wanted to prove by the benchmarks that we'll see in the next slides. So if you have been in earlier DevCons, you probably remember these slides already. I'm not going to go too much into the detail of this, but it's more of a visual representation of what changed between Alfresco 3 and 4 in some key operations. So in this case is really the node creation. In Alfresco 3, as I mentioned before, you had the whole DB-related operations. Within the transaction, the content would be indexed. So as you might imagine, I/O access, this is a very I/O-intensive operation. And this means that if you have multiple concurrent users doing operations, they will all contend for the file system to actually write in a synchronous way in the index. So again, this transactional index consistency has its advantage from a programming standpoint, but doesn't allow to separate concern, distribute load, and obviously doesn't allow to reach the performances that now Alfresco 4 has. So this is the very same process in Alfresco 4. You can see that there's nothing related to indexing. It's pretty much the same process, but the indexing is deferred. It's eventually will be taken care of by Solr. Yeah? So there is a background process that every 15 seconds actually tracks information back from the repository.
Is there a way to reduce the amount of time? Instead of 15 seconds, can you make 10 seconds?
Yes, you can make it 10 seconds, yes. But I think, yes, you can definitely make it shorter. But since programming against time is not really a good practice, you still have to be aware that that's eventually consistent. Meaning, you don't want to assume, yes, the frequency of tracking, the period of tracking can be made obviously more frequent, but still, if the amount of content that needs to be indexed is a lot, you cannot really be sure of when content is going to be indexed. You know that it eventually is going to be there, but you don't want to make assumption in your custom code, relying on search for transactional operations. Same thing goes for search. As I mentioned before, in Alfresco 3, you would first have a whole Lucene step in which the results would be fetched and not filtered. And then you would have a second pass to actually enforce permission results. If you work with Alfresco 3, you know that this might lead to some search results inconsistency, meaning different numbers of results returned at different times because there is a timeout on permission checks. It really depends on the load of your system and the CPU power of your system on how consistent the search results return would be. So in Alfresco 4, this has been changed pretty much completely. Once again, it's now done in flight during the query. So when the repository issues a search to Solr, that query also includes the current logged in user information if you want. So that Solr in flight can actually enforce permissions through the concept of ACL filters. Yeah. So once again, we don't have this double loop, and also the load of checking permissions is actually moved from the Alfresco tier to the Solr tier. Yeah. That's for you to understand really the basic concept that allow you to design the architecture. So the point of having benchmark is that, yes, this is a really nice in paper. The design of Alfresco 4 has been, I think, greatly improved from a scalability and overall performance standpoint, and as well as load distribution. But the idea of running formal benchmarks at every single release, and obviously here we're talking mostly about Alfresco Enterprise, allow us to really get to a next level of understanding of the platform. And there are a few areas, actually, few departments, as well as external stakeholders for the benchmarks. I have been an SC for a few years. I've been a consultant for a few years. And I have to say that I have always been basing my sizing on existing information, so an existing experience from the field. I'm pretty sure that if you work on Alfresco, you have to do this kind of guesstimate game in terms of sizing the system up until now. But the good thing is that right now, a little bit like St. Thomas, we have the proof. We can actually check before giving a recommendation. We have some reference point that we can use as a starting point. So not only for the field, obviously, and I'm a consultant, so for me it's quite important, but obviously this allows to uncover and unveil potential product bottlenecks and to verify that the scalability of Alfresco 4 was really actually strongly improved with respect to Alfresco 3. And obviously, that's more important for our beloved customer partners and community, having reference milestones to actually size your system properly, being able to preemptively solve performance problems because they actually don't come out instead of having maybe later to troubleshoot them. So that's really the main purposes of the benchmarks. And I promised last year when I gave this presentation that a number of benchmarks would have been started. And I'm here to tell you that actually that happened. We started and formalized the full benchmarking process. We will be especially focusing today on two of the benchmarks, which are BM001 and BM009, that are benchmarks that I have personally participated in. Especially BM001 has been really the first, fully fledged scalability benchmark that we run against Alfresco. And if you are an enterprise customer, you can find a full descriptive paper in the Alfresco support website. It's called the Alfresco 4 Scalability Blueprint. It's really very detailed and basically goes through in a whole lot of detail on the results and the setup that we will be discussing today. So I won't go in the detail of all the benchmarks that we run, but just for you to know, we have a process in place. Most of these benchmarks are actually run at every single release right now as part of the default QA process, obviously for Alfresco Enterprise. So there are a few common factors between the two benchmarks that we will be discussing today. As I said, BM001 is a full scalability benchmark. BM009 was really mostly a real-life scenario, setting up a real-life repository as much as possible close to potential customer implementations, trying to also fill the repository with bits which in the past might have created some scalability issues. So there are a few common factors that I'm gonna start with about these two benchmarks. Obviously, we use the same lab. As I mentioned before, the scenario is well defined. We have the so-called, what we define as enterprise collaboration scenario. So fair amount of users, of concurrent users, around the millions of content. We will discuss this. But mostly around shared collaboration. Yeah. In the field, I see mostly two types of solutions, if you want, on Alfresco. One is the enterprise collaboration scenario. The other one is more the content platform, API-based interaction with Alfresco. We are not covering that today. So just for you to know, this is really mostly around collaboration on Alfresco. In terms of technologies, we use, obviously, Alfresco Enterprise and JMeter to actually run this benchmark. We'll see that we are now working on a bit more advanced solutions to actually benchmark our product. Now that we are going to cloud scale, JMeter actually is not the best tool, but we will discuss that a little bit later in the presentation. There are a few differences, and we will discuss them. Obviously, the scripts are not exactly the same, the testing scripts, the database, and obviously the content of the repository. So in terms of hardware, and again, this is really not going to go fully in the details of this slide. It's a bit busy, if you want, but I think this is really interesting, and I was going to leave it here in the presentation, mostly to provide you a reference on which platform, which hardware we actually used to achieve the results that we will be seeing later. So we had dedicated machines for pretty much any tier of the Alfresco architecture. As Roman was discussing before, we might have separate web tier, content tier with Alfresco repository, index tier with Solr, as well as obviously a shared storage and a database. So this lab was fully physical. I've been asked a couple of times if we have any measure around VMs. Obviously, especially for BM001, which was a scalability statistical benchmark, if you want, running that on VMs on cloud environment is a strong complexity factor, meaning you need to have a common baseline, a strong hardware, physical, bare metal baseline to actually being able to rely on the results that you run. Because in a virtual environment, on a cloud environment, you might have twice the same run and having different results because maybe resources are used somewhere else. So the choice was always to go with bare metal to make sure that the baseline was solid. Not going too much into detail, but just make sure that you have enough RAM, especially for the index tier. We will see later why this is needed. As well as, obviously, we had quite high-powered machines. So we're talking about here a dual hexa-core. So in terms of Alfresco sales CPU, we had 3 CPUs per server, so each one 4 cores. So the objective of BM001 was really to do a statistic analysis on scalability. So the idea was, let's tune the platform best effort before, as much as we know that we can make it scale, but do not change it between the different data points. Meaning, let's see with the predefined tuning where we can get to and how the performances of Alfresco and the load on the different tiers will be impacted by this. Yeah. Obviously, we will see that actually the scenario was really, really search intensive. I want to spend a couple of minutes on this slide because, I think this gives us a good insight, as Romain was saying before, of you need to study, you need to know what you're dealing with, you need to know what the scenario is. Especially now that you know that Alfresco 4 has a separate indexing tier. Say one of the questions that I normally ask, and I used to do as a partner, or even as an Alfresco consultant, where I'm trying to characterize the load that I will have on the system, is really what's your number of concurrent users? What's your read-write split? Yeah, that's a pretty much common question that you ask. I mean, what are your users actually doing, reading or writing from the system? That really impacts in a very different way the scalability of your system. I think another fundamental question that you want to ask here is also how many searches, what is the pattern of access, even in case they're reading, what are they using? Are they searching or are they browsing the content? And that's really because I know it's difficult to know it beforehand. I don't deny that, but this really impacts very differently the component that you're actually in need for scaling in Alfresco. So back to our BM001, we had a fairly search-intensive scenario. Almost 48% of the operations were actually searches. This is much more than a realistic, if you want, user interaction. A user typically would use 10, 20% of searches, and they're really search-intensive scenarios that way. So this was really also to validate all the improvements and the changes done on Solr. Yeah. As we said, this was a scalability statistical benchmark. So we had to define which dimensions our data points would live in. Obviously, as we said before, a couple of these dimensions are pretty intuitive. We wanted to study the behavior and the scalability of Alfresco across multiple points of concurrent users, and obviously different amounts of content in the repository. I think that's quite intuitive that we wanted to know something like this. We added actually a third dimension, which is the number of Alfresco cluster nodes. So we basically have a three-dimensional search space in which we defined our data points. And against each of these data points, we ran the same test so that we could compare, if you want, and graph the scalability, the statistical scalability of Alfresco. One little more point about these slides. So these are actually the points that we selected. BM001 in terms of number of content items was about, we tested against 500,000 documents, 2 million documents, and 10 million documents. While the number of users, and that might even be more interesting, we tested against 180, 1,360, 720, and even about 1,100 concurrent users. Yeah. So these are concurrent users. I skipped the slide before, but we had think time 10 seconds, which is also quite, aggressive. I know that other ECM platforms use even 20 or 30 seconds think time. Think time is defined as the, sleep time between users' operation. And if you think about a real user, a click every 10 seconds on an ECM platform, I think it's a bit, it's quite aggressive. So these are very, very concurrent users. Now, the architecture, you might have seen this slide already, but this is the architecture that we used in the first benchmark in BM001. We had obviously a client here running JMeter to actually execute the tests. We had one instance dedicated for share that through a load balancer would connect to 1 up to 4 Alfrescos. As we said, we tested against different Alfresco cluster configurations. Alfresco itself would actually go to Solr, once again, through a load balancer. We had to scale the Solr tier up to 4 nodes, even here, in certain data points. And obviously then connecting through JDBC and NFS to the various data tier components. Now, there's one little thing that probably is not that clear from this slide, is that we also deployed Alfresco instances in the Solr application server. Yeah? So you can see a little loop back here on Solr actually going to a localhost instance of Alfresco for tracking purposes. There are it's a two-way interaction between Alfresco and Solr. So one thing is obviously Alfresco going to Solr for issuing searches, and that's probably the most intuitive use case. But on the other hand, Solr has to, as we said before, has to track content, has to keep its index up to date with the updates that happen in the repository. Now, in order to provide this architecture further scalability, instead of having Solr going back to the front-end nodes, we just deployed another Alfresco on the loopback interface so that Solr would have dedicated tracking capability. I think this is a good, this has shown to be a very good distribution if you want another additional level of scalability, because it allows you to configure the tracking in a totally separate way from your front end, and the tracking itself not impacting any operation that happens in the front end. Very quickly, in terms of software, BM001 was executed on an early Alfresco 4.0, so it can only be better now. And we used Tomcat and Postgres. I'm just showing this one because this is one of the main differences. The other benchmark was actually run against MySQL. As a load balancer, we used HTTPD, just in case we use the software load balancer, no hardware load balancer. I think that HTTPD plus mode AJP, mode proxy balancer give a quite a good deal of configurability and even control. So finally, after all this talking, this is an overview of the results of this benchmark. As I said, we ran this against different data points, so I'm not going to go through the average response time in each and every single data point, but as you can see, this is given in milliseconds. So as you can see, we pretty much had on the top left part, these are the lowest data points. So if you want to know how to read this, this is 500K documents in the repository, 360 users. It had an average time of 0.367 per each operation. I think the most interesting data is this one, obviously. We ran 1,100 concurrent users on a 10 million documents repository doing heavy search-intensive operation, as we have seen before from the scenario, and still having an average response time, which I think it's fairly acceptable, around 1.5 seconds. So again, this is for any operation, including, let's say, it's an average response time for all the operations, so including search, read, writes. And the split is the one that we've seen before. So again, this is shared collaboration, so this is mostly document-oriented, document creation, document preview, search of a document, wiki blogs, and all the other functionality were not tested here. So this is really pretty much document library share interaction. Yeah. So I think this is already a very interesting result. We had some comparative benchmarks with Lucene. So 4.0 using Lucene, there's no way that we could get to these numbers and to 1,100 heavily concurrent users issuing searches with the Lucene subsystem. Yeah, that's just for you to know. So just to make it in short, in other words, Alfresco rocks. Yeah. So couple of takeaways. As I said, it's very good. We would never have got to 1,100 heavily concurrent users with Lucene. The high search intensive scenario meant that we had pretty much a 101 factor between scaling Alfresco and scaling Solr. So anytime we had to add a new repository because of the load, pretty much the same needed to be done on the Solr tier. So we had to add, let's say that in this particular scenario, Solr was more the bottleneck than the repository. That's why, again, it's so important for you to know what you're dealing with. If your scenario is 50% searches, then you want to most probably scale out much more Solr than you want to do with Alfresco, because Alfresco is going to take care of basic content management, but all the searches are on the Solr side. Yeah. We noticed that Solr can be quite memory intensive. This has been improved more and more over the versions, but as I said before, now Solr also take care of the ACL checks. So imagine issuing a very generic search that returns millions of results that have to be cross-referenced with all the potentially complex ACL information. In that case, we went really up in memory. So just make sure you give enough memory. For the benchmark, we had, I think, at least 20 gig given to each Solr instance. And obviously, depending on your scenario, scale out the proper component. I mentioned this quickly before. A full report on this benchmark, and obviously more on even the study of Alfresco 4 scalability is available at support.alfresco.com. So for those of you who are enterprise customers or partners, I really suggest you to do that. It's a bit, I tend to be quite verbose, so it's more than 100 pages, but if you have a little bit of time, I'm sure it will make you fall asleep very nicely. So, because you have insomnia. Any questions on this? I'll obviously try to take questions at the end, but before we move into the other benchmark. Okay, so as I said, BM001 was really a statistical study. BM009 is more of a real life scenario. So we really configured, starting from the experience from the field, we configured the repository to be really potentially almost a copy of an existing repository. So we added a huge number of users, a huge number of groups, at least 50,000, it was I think 10,000 sites, lots of memberships. So really trying to stress all the components that we didn't in benchmark 1, yeah? The other thing is we tried to create an infrastructure and architecture which is more real life. Yeah? Obviously, 4 Alfrescos and 4 Solrs is not really the typical deal. Yeah? It's quite of a high-end deal. So in this case, we decided to get 2 Alfresco and 2 Solrs and see the max we could do with that. A little bit less think time, 15 seconds this time instead of 10, and much less search intensive than BM001. So as you see, this is a more realistic scenario. I normally work, in terms of commercial benchmarks, we work with 80% reads, 20% writes will be already a quite write-intensive scenario. So this basically has 10% writes, 5% searches, and a large amount of read operation as typically collaboration platform is about. As I said, the repository details are really important, and the devil is in the details. So in this case, we really try to make something, gather our experience from the field and create something that is typically found in the field. So obviously, this is a large implementation, but we have 10,000 sites. We have a quite complex ACL distribution and membership distributions on the site, lots of users in the repo, lots of groups. So to try to also stress, if you want, not just the search tier, but also the database tier of Alfresco. All this information is actually stored in different tables in the database. So we really wanted to make sure this was a very realistic benchmark. 10 million documents, 10 million of child associations, so relationship with objects, between objects. So, quite a large scale but realistic scenario. Architecture was pretty much the same as we saw before, only we have 2 Alfrescos and 2 Solrs instead of 4. Yeah? And once again, Solr has his own dedicated Alfresco for tracking. Just quickly on the software, just only the differences with what we've seen before. Still we're running on Tomcat, same machine as we've seen before in terms of specs, but we ran this on Alfresco 4.1.1.2. So really, it was just barely completed. And we actually use MySQL because that's also one of the most common platforms that we see Alfresco deployed on. So really, we wanted a real life, as much as possible, benchmark. As you can see, differently from the other benchmark, this is not a statistical benchmark. We just decided, 3 data points, in terms of number of concurrent users. And without changing architecture, without changing the repository content, we measured, once again, the average response time. Now, There has been some modifications also in the script that we ran. As you might imagine, running testing an Ajax application like share, it is quite complex with JMeter. JMeter has the limitation of not interpreting JavaScript. So you really have to recreate all the Ajax interaction in the JMeter test. So in this test, we actually made it a bit more complex. We actually mimicked much more the share interaction. And even though the test was much more complicated and the repository much more realistic, I think we kept a very good average response time. As you can see, for 200 users, we were 200 very concurrent users, we were in a sub-second response, and even the 500 concurrent users still kept, was around 1 second. So I think these were really, especially for the layout of the repository and the complexity of the test, these were really, really satisfactory results. So once again, Alfresco rocks. In terms of conclusions, apart from mentioning the Alfresco rocks, which you might have guessed already, even with a very realistic and very thoroughly spec'd, if you want, scenario, we were able to keep, I think, a very decent response time. And by starting here, the Alfresco dedicated tracking, so having an Alfresco instance dedicated for Solr tracking didn't show huge advantages in terms of performances, but it definitely shows an advantage in terms of maintainability and operational simplicity of the platform. Because, especially in terms of tuning, most of times your front-end instance requires a different tuning from the tracking instance. Just to give you an example, if you want to disable full text indexing, what you're going to do is stop transformations on your Alfresco instance. Yeah? If you stop transformation on your Alfresco instance, your index will be without full text indexing. Now, if you were tracking from the front-end instance, that would be just not possible, because you would maybe disrupting also other functionalities of Alfresco, like previews, like thumbnails. So having a separate Alfresco instance for your tracking and one for your user serving is definitely a good operational practice. Now, a couple of takeaways. You need to allow enough open files. This is really some of the basics that you need to make sure, even before you start tuning Alfresco. Make sure your system allows enough open files. I normally work with unlimited or 65,000, just to make sure, especially for Solr, that you don't run out of file handles. Make sure that if you tune the Alfresco DB pool, also the database on the other side should accept enough connection. Otherwise, you're gonna end up with a bottleneck. Same thing goes for Tomcat threads. Just for you to know, don't exaggerate here. Otherwise, you might run in a very strong thread contention or resources. So we actually ran, the last benchmark was actually run with 250 threads in Tomcat, which is not a huge amount. Even when we were running 500 concurrent users doing Ajax parallel requests, we never needed to go upper than that. So 1,000 is definitely a lot. Yeah? And I tell you that by personal experience and blood spilling. There was one thing that might be not that intuitive, that it's disabling the antivirus. At the beginning, we started run testing, and we had a ClamAV antivirus running as part of the Red Hat distribution. That was on, especially on the indexing tier, and it was killing performances, because it was trying to check every single file that Solr was creating and changing and merging. So again, it's a corner case, but just doesn't harm for you to double check. And yes, many times, this is more really from my field experience, many times the problem lies in the balancer. And again, not saying that I'm not trying to put away problems from Alfresco, but if you're testing a cluster, just first run half of the test against one node to make sure that the application is functionally working. Then move into the full cluster test. Yeah, that's a good incremental approach. From a more Alfresco standpoint, there are a few areas. Obviously, again, in the scalability blueprint, this is all much more detailed, but obviously you really have to make sure that Alfresco, since it leverages a number of underlying components, has enough access to those components. So make sure the DB pool is tuned, as well as obviously on the other side, your database can receive enough connections, as well as make sure that Alfresco has enough connections to connect to Solr, to issue searches. On the Solr side, there are a few areas that that might have a look at. Again, we didn't really need to change it too much. But again, if you're in a corner case, you might want to change the number of threads that are tracking content, as well as the number of connections that go back to Alfresco. You really need to understand the dynamics that's going on in there, and you will find tuning parameters for each of those communications. We discussed already the benefits of dedicated versus shared tracking. As I said, rather than going back to the front end, I'm much more fond of Solr that uses a loopback interface, also in terms of performance and in terms of overload of the balancer, if you want. It's much easier to have a local Alfresco there. So I'm just gonna conclude with a little bit the future. So I'm probably gonna steal 5 minutes, but I'm Italian, so nobody expects me to be on time anyway. So we found out that JMeter has certain limitations. When you actually go into, we already discussed the limitations in AJAX interaction mimicking, because obviously it doesn't interpret AJAX. So if you want to do a full-blown JMeter test, you basically will have to rewrite the logic that your AJAX calls do, all in JMeter, and that's really can become a quite tedious and unmaintainable task. So the second point is that it's very memory intensive. So we are now in the cloud. We have to do cloud scale testing, and therefore JMeter doesn't really, it's not really a good fit for when you're gonna go up to tens of thousands of users, if you want, in your repository. So what happened is that in the last year, as part of the benchmark effort, and thanks also to great members of the benchmark team like Michael, we worked on creating a super scalable, if you want, benchmark framework. I'm not going to go too much in the history, but as I said, we approached the benchmark effort a few years ago, but it's really until this year when we ran these benchmarks that I've been presenting, and where we actually started building a full-blown benchmark framework that actually, let's say, this is a dignified part of our QA process, if you want. So few quick requirements, and the good thing about this is that it's actually available in the Alfresco SBN, so maybe you might want to have a look at it. The requirements for this new benchmark framework, super scalable benchmark framework, are actually to address some of the shortcomings of JMeter. So being able to, for example, have obviously thousands of active sessions concurrently, but also have durability of your results. So when you're actually running tests through 10 different machines, and again 10 different machines, you want to have a central place where actually consolidate all these results, and being able to even runtime, being able to query against these results. It's really a piece of software, as in you can write your own custom benchmark and package it as a jar. So this becomes really, allows the benchmark to become really part of your software life cycle. And in terms of execution, that's, I think, the most interesting thing. You have a number of, you can start, stop, and pause, and restart your test. You can have different machines running this test as well as being tested by this benchmark. So again, this probably requires a whole presentation by itself, and hopefully we will be discussing this in the future. But I just wanted you to know that this is available, and it is also quite cool, as it uses a couple of buzzwords. like MongoDB, for example. So you might be interested to having a look at it, but this is really the overall architecture. I think the most interesting bit is that obviously we have custom tests for Alfresco, but this benchmark framework is fully, technology independent, meaning you can test your own application, you can have a specific benchmark created for whatever type of application is under test. Just wrapping up, the architecture is quite simple but very powerful. You have Mongo as the central repository for all the test definitions, for all the test results, and obviously also for the data sets that you might need to initialize in the different repositories that you're running against. We use Zookeeper to actually distribute and manage the configuration of the servers as well as the client that are actually running the tests. The cool thing is that Mongo really, due to its flexibility, allows you to store pretty much whatever results you want in there, thanks to the no schema of is no schema nature, but also allow you to have multiple machines. Since it maintains the state of the test, there might be different executors connecting and running this queue of events that are defined by a test run. So I'm not going to be able to do a demo. I'm a bit late, sounds like, but just for you to know, this is really a very advanced test. As you can see, it allows you also to graph the how the test is going through the time axis, if you want. And you can see here, for example, that you can pause the test. You can see that there's no activity, restart the test. So it's really something that allows you a very strong scalability and flexibility in the benchmark framework. Basically, if you want to test something that is super scalable, your benchmark framework must be more scalable than that. So just concluding, this is all available. Whatever we talked today, so both the JMeter scripts and the new benchmark framework is all available in the Alfresco Open Mirror. We don't have a release out there yet. This is being used for internal purposes, but nothing prevents you to go there, build it, and run it by yourself. Obviously, the JMeter scripts are actually run with Ant, but the whole new benchmark framework is just a set of Maven projects. You can just go there and build it up. As you know, I prefer the latter. But again, I think the point here is we discussed that the scenario is fundamental, but also your environment and your context is fundamental. So when you are trying to do sizing, the best way to actually do it, and now we are providing you tools to do it, is benchmark a POC in your environment. Try to do a downscaled example of what you're trying to build and benchmark it in your environment. So we said already Alfresco rocks. I think so, yeah. Yeah, suppose. The new benchmark framework allows you to scale even more your tests. Now these benchmarks are actually part of the Alfresco QA lifecycle, Alfresco Enterprise QA lifecycle. So we know that from now on, the results that we achieved should be achieved in any of the following versions. And these tools are open source, so build your own benchmark. Unless, I suppose there might be questions, but I'm quite out of time.
We can have a few more questions.
No questions? Okay, then sounds like I'm on time. Thank you.